Todavía no. We are going to present non-parametric data analysis earthquake present in a cube near Fiji since 1964. The proposed topic exposed magnitude greater than the 4 Richter of earthquake present in a cube near Fiji since 1964. The database represents a sample of 1,000 observations of this magnitude, together with the variable of longitude, latitude, depth, and number of stations that report. From the information and analysis is done with non-parametric statistical tests in order to obtain if there is normality. If there is a difference in medians between the data or the relationship chosen from the quakes database in order to draw conclusion. The analysis of this database is not direct to someone exactly, but it can help to research in this file or geologists who are interested in the study of earthquakes and who observe the variable of longitude, latitude, depth, and number of stations that report as a variable that can affect magnitude of the earthquakes.
First of all, we did an empirical cumulative distribution function to see the distribution of the magnitude sample, and that's what the graphic shows. The second thing that we did is Kolmogorov-Smirnov test to show if the magnitude of the earthquakes behaves normal, and the result was that the distribution of the magnitude didn't have a normal distribution. Then we did a Kruskal-Wallis to verify if there is any difference in the median of the Richter magnitude scale of the earthquakes, according to the number of the stations that reported it. So the tests conclude that there is a difference, and because the p-value was under the level of confidence. And if we look at that graphic, we can see a clearly difference. Then another test that we did to prove our variables was Spearman correlation. And the only variables that had and positive association was number of stations that reported the earthquake and the magnitude. We can see that in the lower right corner of the presentation.
Flickner test. Well, we choose that because since the data did not come from a normal distribution, it was decided to carry a Flickner test. This test was from the variable magnitude and station since there is high correlation between them. The hypotheses raised in this are the following. Null hypothesis, no significant difference is found between the variants, and alternative hypothesis, significant difference is found between the variants. Okay, as the value P is 0.64, the null hypothesis is not rejected. That is, no significant difference is found between the variance of the magnitude and season variables.
Talking about another correlation coefficient, the Kendall correlation will help us to assign a classification of each variable and study the dependency relationship. In this case, they will be each independent variable with the response magnitude. Kendall coefficient values can range from -1 to 1. A positive value can indicate a positive association, as a negative value indicates negative association. As you can see in the first plot, we have latitude on the x-axis and magnitude in the y-axis, and a correlation coefficient of -0.04. It can be interpreted that there is no linear association between the variables. In the second plot is longitude on the x-axis and magnitude of response with a coefficient of -0.09. As the Kendall correlation coefficient is very close to 0, it can be interpreted that there is no linear association between the variables. Then we have depth versus magnitude. With a coefficient of -0.18, there is a low negative linear association between the variables. And finally, the correlation between number of stations and magnitude, with a correlation of 0.64. it is greater than 0.5, it means that there is a strong positive linear association between the variables, stations, and magnitude.
Well, to be able to apply a logistic regression analysis, the variable to be analyzed, that is, the response variable magnitude, must be dichotomous. And to define it as such, we first took an average of its ranges and as a dividing line or limit. That is, the values that are below this value were assigned to the category of 0, while those that are above or equal to this value were assigned to the category of 1. This limit was 5.2. The p-value of all the coefficients of latitude, longitude, depth, and stations were less than a significance level of 0.05, so the null hypothesis was rejected. As a result, coefficients are not significant to explain the magnitude in this model. Due to this result, we tried other options. We also considered the division of data according to its distribution. However, in this density graph of the magnitudes, it can be observed that it is unimodal. So there is no defined separation of groups that we can use as a limit. On the other hand, if we change this division limit of the dichotomous variable to 6.1, which is the scale that causes several damages, the following happens. We see that the coefficients are now significant. However, in the contingency table, we can see that 998 magnitudes were classified in the category of 0, while only 2 of the total of 1,000 magnitudes were classified in the category 1. So we don't see convenient to use this regression model neither. Therefore, we conclude that there is really no logistic regression model that can explain the magnitude with the observed variables of this sample.
As conclusion, for the chosen database, there is no logistic regression model that can explain the response variable. We consider that this happens because the response variable is not a dichotomous variable. On the other hand, we realize that the magnitude and stations variables present a strong positive linear association, since the Kendall correlation coefficient was 0.64 and the Spearman correlation was 0.80. In terms of the skills and learning achieved, there is a compression of several topics of non-parametric analysis for databases, such as the Kruskal-Wallis test that help us to know the behavior of the data with the help of a hypothesis test for the medians of the magnitude, or the Kolmogorov-Smirnov test that help us to determine if the data have normal distribution or not. We were able to identify the type of test that could give us the necessary information to interpret the data according to the characteristics of the test or data. Finally, the use of statistical techniques will always be a way to ensure the reliability of the results, but it's necessary to learn how to discern which test to use for which data. This was all from us. Thank you for your attention.